Okay, so we've looked at slope on a graph and we figured out this rise over run thing. And so now I want to look at sometimes like we're not given a graph, right? Like sometimes graphing paper is not available, sometimes we just don't see it. Sometimes we're looking at a table or just we're given two sets of data, right? Like 2 points, an x and a y and an x and a y. In that case, I want another strategy because sometimes it's helpful to not need to grab some graphing paper to figure out slope every time. Um, and sometimes it's really hard to graph things without knowing what the slope is first. So I think it would be helpful to come up with a strategy where we can calculate slope without a graph. So let's try. If I want to find the slope of a line that contains 2 points, let's call it x1, y1, so an x and a y, and x2, y2, another x and a y, and you know every ordered pair is an x and a y, so that's helpful. We can use the following equation. Okay, so here it is. We're still thinking a change in my y divided by a change in my x. We're still thinking delta y divided by delta x. Okay, that's always in our mind when we're thinking slope. But here's another way to represent this idea, change in the y divided by a change in the x. I can represent a change in my y by taking one y value and subtracting the other. That's just going to give me the distance between those two y values, okay? That's going to give me that vertical change that we've been talking about. So let's write that. The change in my y divided by the same idea. If I take 2 points on the x-axis, subtract them from one another, that's going to give me that distance. That's going to give me that change in my x. And so here it is. This is called the slope formula, and we're going to use this a lot. It's y2 minus y1 divided by x2 minus x1. Okay? So let's try it. Let's find the slope of a line that contains these 2 points, -4, 1, and 2, 3. Let's call this x1, y1, x2, y2. Okay. x1, y1, x2, y2. Good. Let's try. So y2, it goes here. So that's a 3. Minus 1. Divided by, make sure you go back to that original point. 2 minus, be careful here. We're doing minus a -4. Okay? Minus a -4. I always write that in parentheses when that happens. 3 minus 1 is 2. 2 minus a -4 is, like 2 plus 4 is 6, which reduces down to 1/3. Now you're probably saying, Mr. Gibbs, could I have done it in the other order? Does it matter what point I pick? And I'm going to say, no, it doesn't. See, I could have called this y2 and this y1. That way I would have had 1 minus 3 divided by -4 minus 2. This would be 1 minus 3 is -2 divided by -6, which reduces down to 1/3. So it does not matter which point you call x1, y1, and which one you call x2, y2. Now here's a hint though. The points are usually listed from left to right. So you're most often not going to have to cancel out negatives like this if you pick the second point as your x2, y2, and your first point is your x1, y1. But it doesn't matter, as you can see right here. Okay, imagine the images below explain what we just did. Okay, they explain what we just did. Do you see this rise of 2? Oh, look at that. There it is. Do you see this run of 6? There it is. 6. This is up to over 6, which is exactly what we got, didn't we? And we reduce that to 1/3. And if they would have given us like this point right here, that would have been really easy. Up 1 over 3, our slope of 1/3. Okay? And do you see it? Do you see it? This 3 minus 1. This has a y value of 3 that has an x value of 1. Oh, that's 2. This has an x value of 2, or of -4, and 2 minus a -4 gives us that 6. Yes, this is so exciting. Before we get to calculating some more of them, though, I want to pause, and I want you to try to reduce these weird fractions for me, okay? Go. I hope that was very successful for you. If I divide both of these numbers by 3, I get this fraction, -1/3. Just reducing there. Ooh, divide both the numbers by 2, I get 2/5. 4 divided by 1 is just 4. We want to just put these in simplest terms, my friends. -7 divided by 1, oh, that's -7. -2 divided by -3. A negative divided by a negative is a positive number. Those negatives go away. Same thing here. 4 divided by -7. Well, we can just pull that negative sign out front. Okay? And that just makes it easier. These are both the same. Again, we can pull that negative sign out front. That might make something else easier in the future. 0 divided by anything is 0. Oh, this must be a horizontal line, yes? 0 divided by anything is 0. This must be a horizontal line, yeah? Okay, 12 divided by, I don't know. 12 divided by 0. Oh, that must be one of those pesky vertical lines, right? And we're going to write undefined. Anything divided by 0 is undefined. You just can't do it. It's not legal in the world of mathematics. There's no way to break something up into 0 groups. Like, that just doesn't make any sense. Okay? Okay, so your turn, I guess. Go ahead and y2 minus y1 divided by x2 minus x1, the heck out of these, and see what you get. I'm going to say x1, y1, x2, y2. I think that's helpful to always do. That way, like, you can't get it wrong. But somebody in here is going to be lazy and not do that, and then you're going to get them wrong. And then you're going to be like, Mr. Gibbs, why am I getting these wrong? And I'm going to have to come over and look at your work, and I'll be like, oh, what are you doing wrong? And then I'll be like, oh my gosh, you like did a y minus an x. You can't do that. Or you did this y minus this y, but then you did this x, and that doesn't work either. And that'd just be very upsetting instead of just getting 3 halves like you should. Okay, do I need to make this a mixed number? Please don't. Improper fractions are the very best when we're talking about slope, okay? Improper fractions are about the best when we're doing just about anything in algebra. That was so like 6th grade. Like, the only reason you want a mixed fraction is because you can like better understand what its value is, but for practicality purposes, like, not always the most helpful things, yeah? 3 minus a -2 is like 3 plus 2, which is 5. 4 minus, that's 5, okay, simplifies to 5. Moving on, x1, y1, x2, y2. 12 minus 4 divided by -3 minus 0. 8 divided by -3. We could call that -8/3. Move that out front. Although it looks like I just put that with the 8, but whatever. x1, y1, x2, y2. 1 minus 7 divided by negative 3 minus a negative 1. Do you see all those negatives? Make sure that you're subtracting a negative. You put this in parentheses. That'll really help you see it. So negative 6 up on top. Negative 3 minus a negative 1 is the same as negative 3 plus 1, which is the same as 1 minus 3, which is negative 2. Negative 6 divided by negative 2, well, that's a positive 3, because a negative divided by a negative is a positive, and 6 divided by 2 is 3. Continuing, x1, y1, x2, y2. I have a 7 minus 7, ooh, and a negative 11 minus 3. Well, this is 0, so who cares what's on the bottom? What's negative 14? That's overkill. 0 divided by anything is 0. This is a 0 slope. Let me guess. This is going to be undefined, isn't it? Let's try it. (10 minus 4 divided by negative 5 minus a negative 5. This is 6 divided by negative 5 minus a negative 5 is the same as negative 5 plus 5, which is like 5 minus 0, which is 0, which is undefined. We can't do that. This must be a vertical line, huh? Okay, well, I hope that was helpful. And you should know what to work on next. Thank you.